Hey everyone, welcome back to Python Code Nemesis. Today we'll be looking at database queries in Python with SQLAlchemy as well as Postgres. Let's get started. What is Postgres? Postgres is a powerful open source object relational database management system that is widely used for managing large amounts of data. It's known for its reliability, stability, robustness, making it a popular choice for organizations and applications that require high levels of data integrity and security. Postgres supports a variety of data types, including integers, floats, text, and dates, provided by many advanced features such as support for stored procedures, triggers, and views. It also has a strong emphasis on SQL compliance, providing support for complex queries and advanced SQL features such as window functions and common table expressions. PostgreSQL is highly extensible with a robust extension system that allows developers to add new functionality to the database easily. It also cross-platform available, running on Windows, Mac OS, Linux, and many other operating systems. SQLAlchemy. SQLAlchemy is an open source Python library that provides a set of high-level tools and utilities for working with relational databases using Python. It allows developers to interact with a variety of SQL databases using a unified API which abstracts away the differences between the various database engines. SQLAlchemy provides an object-relational mapper (ORM) that allows developers to work with databases using Python objects rather than raw SQL queries. This makes it easier to manage the database schema and data, as well as providing a more Pythonic way of working with the database. SQLAlchemy also provides a SQL expression language, which allows developers to write SQL queries in Python syntax. This makes it easier to write complex queries and manipulate database data using Python code. In addition, SQLAlchemy provides support for connection pooling, transactions, and other common database management features. It also supports a variety of SQL databases using Postgres, MySQL, SQLite, and Oracle. Database queries in Python. First, you need to install Postgres from the official website for your operating system. Once installed, you should be able to start the Postgres server. So this is the link for the community page. Download PostgreSQL 15 from here. Start the setup. So the setup will start up. Choose the data directory from this. Now provide a password and retype that. You can give any super user password like admin1234 or anything. Just that you need to remember this password all the time. Make sure you don't forget it and write it down. It's easier to use password as the password. Next. Select the port number, which is 5432, which is the generic port number. And then there's select locale. So you should be selecting the default locale that will be used by the database cluster. And then the installation will begin. So once this installation and everything is set up is done, then it will be showing you this page where the PostgreSQL setup wizard has completed its work, and you just need to click on finish here. pgadmin4. pgadmin4 is a free and open source administration and management tool for Postgres. It provides a graphical user interface for managing and interacting with Postgres databases, allowing users to create and manage databases, tables, views, users, and other database objects. pgadmin 4 offers a user-friendly interface that simplifies the process of managing PostgreSQL databases. It provides features such as syntax highlighting, code completion, and error highlighting for SQL queries, making it easier for users to write and debug SQL code. It also allows users to create and execute queries using a visual query builder tool. In addition to database management, pgadmin 4 provides tools for server administration, including server settings, server groups, and server logs. It also offers support for backup and restore operations, allowing users to easily backup and restore their databases. pgadmin 4 is available for Windows, Mac OS, and Linux operating systems and can be downloaded for free from the official pgadmin website. So just go to pgadmin, so that will be inside your Postgres folder. And like once you click on it, you will be asked to set a master password the first time you open pgadmin 4. So set like a password, let's say admin1234, that's what I set. Enter your Postgres password, and you'll be coming to this screen where it shows you the dashboard with server sessions, transactions per second, and some more information. Creating a new user. By default, Postgres creates a user called Postgres with full privileges. To create a new user, open a terminal and enter the following command: create user interactive. Follow the prompts to create a new user with the name and password of your choice. Make sure to grant this user a create DB privilege so that they can create new databases. Now with this user, you can create a new database. So open a terminal and enter this command: create DB my database -o my user. Replace my database with any name that you want to give to your database, and my user with the name of the user that you created. This will create a new database with your user as the owner. Now you need to connect to that database. Open a terminal and enter the following command: psql -d my database -u my user. So this will make you connect to your database. psql-d my database -u my user. So psql, then the database is my database and user is my user. So these are the flags. Replace my database again with the name of your database and user respectively. You will be asked for the user password. Now you can get the database connection details by entering this SQL command. So select current user, current database. This will return the username and database name that you can use to connect to your Postgres server. So that's it. You should now have a working Postgres installation with a new database that you can use for this tutorial. To get your Postgres database connection details, you will need to know the following information: the host, which is the host name or IP address of the machine where you're running your Postgres server. If your Postgres server is running on the same machine as your application, you can use localhost or 127.0.0.1 as the host. Port, this is the port number on which your Postgres SQL server is listening for the connections. The default port number for Postgres SQL is 5432. Username, this is the username that you use to connect to your Postgres server. By default, the Postgres user is created using the installation, but you can also create additional users as we did before. Password is the password that we use to authenticate with the Postgres server. In the case of a local installation of Postgres, you may not have set a password for the Postgres user. So when you did, that is the password you need to use. And finally, the database name. So you can find these details in your Postgres configuration files or asking your DB admin in case you're like working with like multiple, like in case you're a user and you have a separate DB admin. Locally, you wouldn't have to because you're already the DB admin. In case you are using a cloud-hosted Postgres, your provider will provide you with the details. Once you have your DB connection details, you can use them to connect to your Postgres SQL server using a Postgres SQL client or command line interface like PSQL. To create the users table in a Postgres SQL database, you can use the following SQL query. So create table users, brackets, ID serial, primary key, name, varchar of 255 not null, email varchar of 255 not null, and age int not null. This will create a table called users with 4 columns: ID, name, email, and age. The ID column is a serial primary key, which means it will automatically increment with new row added to the table. The name, email, and age columns are required fields that cannot be null. In this, you can execute this SQL query with any Postgres SQL client or command line interface, such as PSQL or pgadmin. Here's an example of how you can use the PSQL command line interface to execute the query. So open a terminal window and enter the following command to connect to your Postgres database. Replace host, port, username, and database with your actual database connection details. Once you are connected to the database, enter the following SQL query to create the users table. Create table users. So this is the command that we used before. Press enter to execute the query. So once the query is successful, you'll be able to see the message. So that's it. Now we'll be writing SQL queries with SQLAlchemy. This table has 4 columns: ID, name, email, and age. ID is a serial primary key, which means it automatically increments with each new row. So once each new row is added, it just increments the value of this ID. So let's move on to writing SQL queries in SQLAlchemy. First, we'll need to import the necessary modules. So from SQLAlchemy, import create engine, column, integer, string. From SQLAlchemy.orm, import session maker, and from SQLAlchemy.ext.declarative, import declarative base. Next, we'll create an engine object and connect our Postgres database. Engine equal to create engine, and the URL to our local host Postgres / the database name. So you'll have to replace the database name here. Session equal to session maker, bind equal to engine. So it will bind this engine to the session, and session equal to a new session. Like that is a new object of this class. So now that we are connected to the database, let's start with some very simple SQL queries. But before that, we need to have a declarative base and a class which inherits from this declarative base, which mentions the table name as users and the ID as column number, integer, which is a primary key, name as column of string, email as column of string, and age also as column of integer. So to select all the columns from the users table, you can use the following code. So users equal to session.query user.all. So this will query all the users, and the users will be created in the format of this class. And for user in users, we're printing the user ID, name, email, and age. So this will output a simple list of all the users in the table. To select specific columns, we can use the with entities method. So users.session.query user ID, username dot all. So you can just like select which ones you want to query. This will output only the ID and name columns for each user. I recommend executing all of this code and like changing data constantly to check how it's working. That will be a lot intuitive. Order by. To order the results by a specific column, you can use the order by method. So users equal to session.query users, order by user.age.all. So this will order by in the ascending order of age of all the users. So if, let's say, John has an age of 2 and Akash has an age of 7, then John will come first and then Akash, even if the order of them in the table is different. Distinct. To select only distinct values from the column, we can use the distinct method. So session.query user.age.distinct.all. So it will only query all the distinct users by user.age. So all the distinct ages in the table, let's say some people have 29, some people have 7 as the age, you'll just get all the distinct unique ages in the table. Similarly, if you do it for name, you'll get the unique names in the table. And similarly, if you do it for, let's say, what are the columns? Emails, which is definitely supposed to be distinct, you'll get all the emails. Next, we come to where. To select only certain rows based on a condition, we can use the filter method. Session.query user.filter user.age greater than 30.all. This will output all the users in the table who are older than 30. Now let's move on to a little more complex query. Create a file queries.py and insert all of this code that we just added, right? So the table before you execute this query will look like this. And once you execute the file with queries.py, like I entered some data into this table from pgadmin. So I added like manually. So the name is Python code Nemesis. The email is just a random email and the age is 23. So once we execute this file, the output will look like this. So you can see how it has been able to find out. But now we just had only one entry in the table. So let's see once we add more entries to the table, how the output changes. So added a bunch of new names, like 4 more entries. So let's see what happens now. So yeah, we can see that here we have like a bunch of entries with IDs, different IDs, and then age, which is an integer. So we see that we have different ages, names also are different, and yep. So what is our query? Our query looks like ages greater than 30, right? So for the greater than 30 thing, there should be only one. So yeah, so in this whole table, there's just one age 30, greater than 30 that is, which is Ganesh. So this will be printed. So 32 and Ganesh's details. So all of this is working correctly. You could definitely try and add more stuff in there to check how this works. Joins. To join two tables, we'll need to define them as separate classes in our code. For example, let's say we have another table called orders. Create table orders. This is how you need to create that table. And once you do that, you will be able to see that the table has been correctly created. Now you can add some data. So as you can see, I'm doing all of this from pgadmin 4. So pgadmin is a really, really useful tool when you're working with Postgres, specifically when you want to test a lot of your code as well. So add some data into this orders table, and it will look like this. So ID, user ID and product. So which is product is a string, user ID is an integer, and ID is also an integer. Right, so if we go back, update the queries.py code, add a class order. So we'll need to, like when we query this DB, we also need to have a class showing us the DB. It's like all the columns in the DB so that it can correctly capture it as a Python object. So create a table with SQLAlchemy in Python to map the foreign key column in table 1 and to the primary key column in table 2. You can modify your code as follows. So as you can see, we are having a foreign key relationship. So in table 1, we have a column which is also the foreign key for table 2 dot column. And here we define two SQLAlchemy models, table 1 and table 2, with a one-to-many relationship between them. The foreign key column in table 1, which is this one, is defined as using the foreign key function, which specifies the name of the target column that it references. The relationship function here is used to define the corresponding relationship attribute in table 1 that allows access to the related rows in table 2. So this will allow access to the related rows in table 2. All the code for this tutorial is available on my GitHub, Python code Nemesis. So feel free to check that out. And that's it for this article. Thanks for watching this video. If you found this helpful, please like and subscribe. And if you want to know more about Python frameworks, keep watching. Have a nice day and happy coding.